This learning session is created by the ISG training team and is intended for use by ISRs in Dell Medium Business. We're going to talk about server virtualization, what it is, and why it makes sense. But first, let's discuss and look at how virtualization was born and the problems that it solves. In the beginning, when people needed to run an application that was mission critical or could not go down or had to have as little downtime as possible, folks would actually put an operating system onto a server and they would run a single app on the server. Now, this app was so important to the business environment that it was okay to have one app on a server. So if they needed a second app, they would load an operating system onto the second server, and they would load the second app onto that operating system. Now, it's the same story if they needed a third application. They would install an operating system and install that app on that one. Now, in the meantime, we have a lot of wasted resources. So if we have, for example, a terabyte of space on a server, but we're only using maybe 50 meg, that's an extraordinary waste of disk space. Sometimes I equate a situation in which we have bought too many resources and put a single app on a server to maybe building a spare room for your goldfish, even though your goldfish just needs that little bit of space inside its bowl. So it can be a huge waste of resources to run a single app on a single server. Realizing this over time, we figured out some other way to do this. So it's entirely possible that our top server maybe has way more storage than it needs. The middle server, perhaps it is using its storage well, but it has way more processing power than is actually needed. We can theorize that the bottom server perhaps has way more disk space than it actually needs. In all cases, we have wasted resources. To explain how apps use different amounts of resources, let's imagine a dinner scenario. So imagine you're going to be serving 3 items for dinner this weekend. You're going to serve a meal with beef, beans, and rolls. And your dinner guests are going to be Jim, Anna, and we'll say Sunset. Now, Jim likes beef, and he will consume a lot more beef than the other two. Anna is going to eat a few beans, and Sunset is going to eat a lot of rolls. All of them will devour different amounts of each ingredient. Perhaps if we have too much Jim on one server, then we don't have any beef at all. Sunset, meanwhile, is eating a lot of beans and consuming a lot of rolls. Now imagine these are server resources. Perhaps beef is actually the processor. Perhaps we think of beans as being disk space, and instead of rolls, we have RAM. Now imagine Jim and Anna and Sunset. Instead of people, they are apps, all consuming different resources on a server. We could see how resources could become scarce. We could see also how maybe one app or even a couple of apps could consume an inordinate amount of resources in one category and maybe very little in another. When one app consumes very little disk space, but maybe we have a lot of disk space on another server, that's not really something that's easily moved over, if that can even be done at all. And resources on a server are usually physically laid out and are not transferable from one to the other. Typically, it's a bad idea to move even physical resources from one server to another. Entering the world of virtualization, a server, if virtualized, will be able to run multiple applications, and we can set it up to where these applications are combined to use either the full resources of the server or at least to utilize more of the resources for which we've paid, so we're not wasting resources or wasting money. This starts with a little piece of software known as the hypervisor. Now, 2 hypervisors that we see pretty commonly in our space are going to be VMware ESXi and Microsoft Hyper-V. You can probably find a few others out there, but those are the 2 that we're going to see most often in medium business. So to understand what the hypervisor does, think of it as a kind of a divider. Every operating system must believe that it is the only OS on that box, whether it's a laptop, workstation, or a server. So if you put 2 operating systems on the same box, that's bad because they're going to fight. They're not going to get along. There's going to be problems. So imagine for a second if you had a dog kennel. If we were to put 2 dogs in the same backyard, possibility that they fight, that would be bad. So we won't do that. What we could do, though, is we could put 2 in the backyard and put a divider between the 2 so that one does not know the other one's there. So here we have 2 dogs and 3 dogs. Here we have multiple dogs all divided up, all believing they are the only one, and they don't fight. And if we give each dog the space that it needs, we're not wasting yard space or wasting yard resources. Eventually, if we find out that one dog actually needs fewer resources, we could give it less resources. Now, let's take that example back over to our server. So the hypervisor can be used to divide up the OSs. So in each division, we can put an operating system similar to the dogs, and we simply add an app on top of each operating system. So each app survives on its own OS, separate from the other ones. By doing this, we can use the server resources to its fullest degree, and each app is isolated on the OS in its own kennel, or its own divided portion of the system. And just like in the backyard, if we find one of these OSs, like one of the dogs, needs more space, we can allocate more space very easily. Imagine needing a new server and having to order a new physical server and set everything up individually, meaning having to configure IP addresses for all the ports, and all the ports on the server, and all the ports also at the other end of the cables to each switch. So overall, we're looking at a few clicks to set up a virtual server versus a lot of work to set up a physical one. So let's come out of the single server scenario and move this over to a 3-2-1. We have our servers at the top, switches in the middle, and at the bottom we have our storage array. As with the single server, our hypervisor will be in green. Each operating system lives on the storage array itself, along with the app that runs on each operating system. I'm going to use 3 in this example, but we could run as many VMs as we want until the resources are maxed out. So this could be hundreds of VMs if we want. In this whiteboard, we see each server has a connection to each switch, and these are probably dual connections, and each switch connects to each controller on the storage array. By virtualizing in this way, we have the ability to move VMs from one server to another. We have the ability to load balance, meaning we can avoid overloading one server with too many VMs. We can spread the workload out across multiple servers where neither one of them are working too hard. We also have better use of system resources, and we get high availability, meaning our apps are available for 99.999% of the time. With this setup, we can lose any server and the VMs can run on another server, so they're not down for long or perhaps not even down at all. We can also lose either of the 2 switches, resulting in very little or no downtime, since a redundant switch is right there to pick up the workload. This concludes Virtualization 101. Thanks for watching and happy selling.